Welcome to the deep dive. Today, we're going to be taking a flashlight into what might be the most talked about and maybe the least understood regulatory document of our time.
That's a good way to put it.
We are talking about ISO 42001.
The standard for an artificial intelligence management system, or AIMS, as you'll hear us call it.
And really, if your organization develops, uses, or let's be honest, even just thinks about artificial intelligence,
Which is pretty much everyone now.
right, then this is, in a way, your new operating manual.
I'd say it's more than a manual. It's really the definitive blueprint for responsible AI. For years, AI was kind of the Wild West. Innovate first, ask the hard ethical questions later.
Ever.
Exactly. But now, AI systems are moving out of those R&D labs and into, well, our core business processes. They're handling customer data, driving strategic decisions, even diagnosing medical conditions. The stakes have just never been higher.
And that's the core challenge, isn't it? AI is now integral, but it brings these unique problems, opacity, the sheer speed of failure, all those inherent biases from the training data. So our listener is really looking for an instructional walkthrough. They don't just want to know what 42001 is. They need to know how it structures a management system to make sure their AI is safe, trustworthy, and crucially, auditable.
Precisely. The goal isn't just about ticking boxes. It's about embedding trustworthiness into the entire AI lifecycle. We're dealing with technology that's evolving incredibly fast, and global regulations, think of the EU AI Act, are emerging just as quickly. So organizations need a structured, auditable way to manage that volatility proactively.
And 42001 provides that.
It provides that globally recognized structure. It allows organizations to maximize the value AI creates while confidently minimizing the risks, both to the business and to society.
So our mission today is pretty straightforward. We're going to treat this deep dive as a kind of high-level instructional guide. We'll walk through the standard, section by section, and make sure you understand not just the idea of AIMS, but more importantly, how this framework can integrate really seamlessly into the management structures you probably already have.
We're unpacking the blueprint for responsible innovation.
Okay, so let's start with the hard definition. If I go to my board and I say, we need an AIMS, what am I actually saying we need to implement?
What you're saying is you're implementing a comprehensive management system, one that covers best practices, governance frameworks, and all the operational requirements designed specifically for artificial intelligence.
So it's not just a piece of software.
Not at all.
Yeah.
Think of it more like the air traffic control system for your entire AI portfolio. And the core philosophy driving it is proactive risk and opportunity management. And that's across the AI system's entire lifespan, from the first idea to the moment you retire the model.
And unlike, say, a standard IT security protocol, this has to account for volatility. AI systems, by their very nature, are designed to learn and change. They can introduce new risks completely unpredictably.
That's the crucial distinction.
Yeah.
Traditional management systems, they manage static processes. 42001 manages a dynamic asset. The risk and opportunity-based approach ensures that as the AI evolves, as new data comes in, as the model drifts, your governance framework evolves right alongside it.
Oh, so it's not a set it and forget it kind of thing.
Absolutely not. It ensures reliability, trustworthiness, and safety are maintained, not just at launch, but continually.
Okay, let's talk strategic imperative. This takes time, money, resources. Why should a company really invest heavily in implementing 42001? What's the high-leverage business case here?
Well, it's a multi-layered value proposition, really. It moves from being a mandatory defense to almost a market offensive. The most immediate driver is, of course, risk mitigation.
The defensive part.
Exactly. AI carries these unique, sometimes catastrophic risks. Algorithmic bias leading to legal action, security breaches exposing proprietary models.
Or just catastrophic failures from model drift.
Right. And 42001 mandates specific controls and procedures to proactively identify and manage these risks before they turn into major incidents.
Okay, so that handles the downside. What about the value you actually get from having this structure in place?
That leads directly to the second point, trust and transparency. In a lot of industries, AI is, suffering from a trust deficit right now. Customers, regulators, even employees are wary of these black box decisions. So by implementing 42001, you as an organization are committing to making your systems auditable, explainable, and fair. And that commitment translates directly into stakeholder confidence, which is a massive market differentiator.
And that confidence becomes a tangible asset, a real.
It absolutely does. And that leads to the third point, which is it becomes a distinct competitive advantage. Achieving certification signals AI maturity and ethical responsibility. In a crowded market, a 42001 certification is like a badge of honor. It opens doors to partnerships, contracts, especially with public sector or heavily regulated partners who need demonstrable governance.
I have to imagine the regulatory tsunami that's building globally is driving this urgency more than anything
Oh,
else.
absolutely. That's the fourth driver. Regulatory alignment. You just have to look at the EU AI Act, which classifies AI risks and imposes some very strict compliance requirements. Organizations that are using 42001 are, in effect, future-proofing themselves. They're establishing the management structures they'll need to meet these emerging global standards.
So it turns a potential compliance crisis into just a manageable operational task.
That's a great way to put it, yeah.
You also mentioned some practical business benefits, things that are maybe less about reputation and more about the bottom line.
Right, that's the fifth point, operational efficiency. By standardizing the AI lifecycle, from data collection all the way to model deployment and monitoring, you get rid of those fragmented ad hoc approaches that so often lead to costly errors and rework.
And that standardization improves consistency, system reliability.
And it reduces the cost of failure, definitely.
And finally, it seems to tackle that perennial problem of accountability, especially with cutting-edge tech.
Yes, and that's the critical sixth point, establishing governance and accountability. 42001 forces top management to assign clear roles and responsibilities. So when an AI decision goes wrong, there should be no ambiguity about who owns the data, who validated the model, and who is ultimately accountable for the outcome. That clear oversight is vital if you want to scale AI responsibly.
Okay, let's define the scope a bit more. We've established this isn't just for, Google or OpenAI. Who really needs to be paying attention to 42001?
The scope is intentionally broad. It applies to any organization, regardless of size, sector, or geography, that develops, deploys, or even just uses AI systems.
So a small bank using a third-party AI for credit risk.
They need an AIMS just as much as a global manufacturing firm that's optimizing its supply chain with its own proprietary models.
So if I buy an off-the-shelf system, I can't just assume the vendor is a 42001 compliant and my use of it is fine.
That's exactly right. You still own the governance around the application of that system, the data you feed it, the decisions you let it make, and the oversight you maintain.
I see.
And on top of that, the standard covers all modalities of AI, machine learning, deep learning, NLP, computer vision, and it really permeates all functions.
Yeah.
Customer service, finance, HR, strategic decision support. It's an enterprise-wide mandate for any area touched by autonomous decision-making.
That makes the distinction between 42001 and other standards even more critical then. Since the structure is shared with standards for quality or security, what are the foundational AI-specific themes that 42001 brings to the table that go beyond those typical management standards?
This is really the core of the standard's innovation. It introduces 5 mandatory elements that have to be woven into the governance framework.
Okay, let's start with the values system that's required for AI.
First is AI ethics and values-based decision-making. This isn't abstract. It requires the organization to codify its ethical stance. You have to define what fairness means in your specific context, and then establish policies to ensure AI outcomes align with both organizational and, well, broader societal values. It's management committing to a human-centric approach.
And what about the black box problem? How does 42001 tackle that?
It does that through algorithmic transparency and explainability, XAI. So if an AI system makes a consequential decision, let's say it flags a financial transaction as suspicious, the organization has to be able to generate a clear, comprehensible explanation for that decision.
So you can't just say, the computer said so.
No. 42001 mandates processes to promote interpretability, ensuring that decisions are not arbitrary and can be challenged or audited.
That leads naturally to the biggest hot-button issue in AI bias.
And it addresses that with bias and fairness assessment. This is a proactive requirement. Organizations must not wait for a public scandal to discover biases in their systems.
So you have to go looking for it.
You have to. 42001 mandates regular systematic evaluation of AI models across different demographic groups or data slices to detect and mitigate potential discriminatory outcomes. It moves bias from just a theoretical concern to a measured operational metric.
And I see the outline refers to this in the context of the model's fuel, which is the data.
Yes, that's AI data governance and traceability. AI relies on these massive, often sensitive data sets. 42001 requires robust policies for data quality, ensuring integrity, and critically, provenance.
Provenance, so where the data came from.
Exactly. And unlike traditional data management, you have to maintain a documented history, a trail of breadcrumbs for the training data, the model version, the testing results. This detailed traceability, or what it calls AI system lifecycle management, is essential for debugging, for compliance, and for auditability.
It sounds like the key shift is demanding not just what the AI did, but why it did it, and being able to prove where the data came from that led to that decision.
That's it, exactly. It mandates moving away from simply tracking output accuracy to tracking accountability and the ethical fidelity of the inputs.
We've established that 42001 is specialized, but it doesn't stand alone. It's built using the NXSL high-level structure, or HLS. For listeners who aren't, steeped in ISO standards, why does this technical structure matter? What does it bring to AI governance?
The HLS is foundational, really. It provides a common, uniform template, core text, and standard terminology for virtually all modern ISO management system standards.
Like 9001 for quality or 20001 for security.
Or 31000 for risk, yeah.
So why standardize the structure like that?
Well, for one primary reason: integration and efficiency. All these standards now share the same 10 main clauses and the same sequence: context, leadership, planning, support, operation, and so on. So if your organization is already certified in, say, ISO 27001 for security, you're already familiar with the structure, the terminology, the audit process.
Okay, so it drastically streamlines implementation.
It does. It prevents conflicting requirements and dramatically reduces the implementation effort. You're simply slotting these new AI requirements into an existing, proven governance chassis.
That makes perfect sense. So the structure isn't an extra burden, it's an accelerator. Let's dive into those specific synergies. If I'm already ISO compliant, how does 42001 leverage my existing systems?
Let's map it out with the most common systems. Take ISO 9001 quality management. Organizations use that Plan, Do, Check, Act cycle, the PDCA cycle, to ensure consistent process quality. With AI, you leverage that existing system to guarantee that the AI outputs, the decisions, the predictions, meet your defined quality objectives. The PDCA loop becomes the engine for continuous improvement in your AI system's performance, its ethical adherence, and its governance structure.
So the quality assurance framework you already have now simply has AI decisions added as a measurable output.
Precisely. Next, let's consider ISO 27001 information security. AI systems have massive security risks, protecting the model architecture, securing the training data, defending against adversarial attacks.
You don't need a whole separate AI security department then.
You shouldn't. You integrate AI security controls right into your existing information security management system, your ISMS, your current access control, encryption, data protection policies. They just expand their scope to cover all the AI-related assets.
What about the central theme of risk? How does 42001 prevent us from, building an entirely new risk framework from scratch?
That's where ISO 31000 risk management comes in. 42001 requires systematic management of all those ethical, operational, and regulatory AI risks. So instead of creating a separate AI risk register, you integrate these specific AI risks, like algorithmic bias or model drift, into your existing enterprise risk register.
And 31000 provides the method for that.
It provides the established methodology for identification, analysis, and treatment. It makes these new AI risks manageable within your familiar organizational procedures.
And finally, data privacy. That's almost always a challenge with these huge training data sets.
And that links directly to ISO 27701, Privacy Information Management. If your AI system is trained on or processes personal data, 42001 requires that your existing data protection controls like data minimization, privacy impact assessments, consent management are seamlessly integrated.
So it ensures your AI innovation doesn't violate GDPR, CCPA, or other privacy regulations.
Yeah.
The benefits of this integration seem enormous. You avoid redundancy, you increase the efficiency of compliance teams, and you're strengthening compliance across multiple regulatory spheres at the same time.
It absolutely prevents AI governance from becoming this siloed, fragile operation. It ensures that it's embedded, durable, and cost-effective.
Now let's go back to that philosophy we opened with. Risk and opportunity-based thinking. How does 42001 actually operationalize this duality throughout the 10 clauses? It's hard to imagine being simultaneously risk-averse and innovative.
And that's the management challenge this standard forces you to solve. Risk-based thinking is your defensive layer. It's a systematic process where management uses tools like risk registers, scenario analysis to anticipate, evaluate, and mitigate potential harm. The standard is very explicit. You have to manage operational risks.
Like model failure, downtime.
Right. Ethical risks like unfair outcomes, regulatory risks like fines for noncompliance, and of course, reputational risks like public backlash.
It's the structured management of failure potential.
Correct. But then the standard also mandates opportunity-based thinking. This is your offensive layer. You must systematically identify areas where AI can deliver significant business value. That could be process automation leading to cost savings, enhanced insights driving market advantage, or innovation enablement creating entirely new product lines.
So you're compelled to pursue those opportunities.
Yes, but only under the controlled, auditable environment that's been established by your risk mitigation framework. You innovate responsibly, not recklessly.
Let's now move into the core instructional part of our deep dive, the 10 clauses of 42001. Since we're trying to integrate this into existing ISO knowledge, we won't get hung up on the boilerplate, but we'll definitely focus on the unique AI requirements in each section, starting with Section 1, Scope.
Section 1 is all about drawing the map. It's about setting the boundaries for your aims. You have to clearly define what AI systems, what processes, and what business units are covered by it.
And what's the key pitfall here for organizations?
Ambiguity. It's just ambiguity. You can't govern what you haven't defined. The definition of scope has to explicitly consider your organizational context. So what you do and where you operate, your stakeholder needs, what customers and regulators expect, and of course, the legal and regulatory requirements that apply to your geography and industry.
So you need crystal clear boundaries on what's in and what's out to focus your resources effectively.
Exactly.
Okay, Section 2, normative references. This is where 42001 links back to other authoritative documents. What's the high-level takeaway here?
Simply put, you're aligning your aims with the established technical and ethical ecosystem. These references like ISO 9000 for quality principles or ISO 31000 for risk methodology ensure that your AI governance isn't reinventing the wheel.
It's built on decades of management system experience.
It is. It's all about coherence and using proven methodologies.
Section 3, terms and definitions. We've touched on this, but consistent terminology is so critical for a domain as jargon-heavy as AI. What are the non-negotiable terms that organizations really need to standardize internally?
Beyond the standard management system terms, you need absolute clarity for the AI-specific concepts. Everyone in the organization, from the developer to the CEO, must share the same definition for bias.
Systematic deviation leading to unfair results.
Right. And for explainability, XAI, which is the ability to interpret decisions, algorithmic transparency, which is clarity on how the system works, and human oversight, the actual mechanism for human intervention. Without this standardized vocabulary, training is impossible, and audits just become exercises in misunderstanding.
Okay, moving to Section 4, context of the organization. This clause is foundational because it ensures the aims is strategically relevant. Why can't a company just copy-paste an aims from a template?
Because AI risk is contextual. What's low risk for a predictive maintenance system in a factory could be extremely high risk for an HR hiring algorithm.
Right.
So you have to analyze your own environment. Your internal context includes assessing your organizational culture. Is leadership truly committed to ethics? Your resources, your existing processes. And then the external context requires systematic analysis of global regulations and those broader stakeholder expectations, which are changing constantly.
And the crucial step here seems to be the stakeholder analysis. Who needs to be heard?
Everyone who's affected. That includes your internal AI development teams, of course, but also external customers, regulators, and even representatives of the community the AI system affects. The needs and the ethical expectations of all these parties have to directly inform the design of your AI policy. If you skip that step, you risk building an aims that completely fails to govern the real-world issues your stakeholders actually care about.
Section 5, leadership and commitment. This is where accountability lands. Given the ethical complexity of AI, what is the core requirement for top management?
Accountability from the top is absolutely non-negotiable. Leadership has to demonstrate commitment not just by, signing a policy, but by actively defining the strategic direction and assigning authority. Key requirements here include formally defining the AI ethics policy, establishing a clear governance and accountability structure, who reports to whom on AI risk, and committing resources, time, budget, and competent people.
And how does that commitment translate into action? What does that look like?
They need formal mechanisms. Leadership has to hold, say, AI governance board meetings to review the performance and ethical compliance of critical AI systems. They need to actively promote a culture where transparency is valued and employees are encouraged to flag potential ethical concerns without fear of reprisal.
A passive leadership approach just results in a paper
The
aims.
paper ends with no teeth, exactly.
All right, finally we reach section 6, planning. This is the crucial moment where strategic intent turns into measurable objectives and structured risk mitigation. What's the fundamental mandate of this clause?
The mandate is to ensure the aims is proactive, not reactive. Planning here breaks down into two vital cycles: risk management and setting objectives.
Let's detail the AI risk management required here. You mentioned 3 steps.
That's right. First is identification. You systematically list all the potential ethical, operational, regulatory, and reputational risks associated with your specific AI use cases. Second is assessment. You evaluate the likelihood and the impact of each of those risks. For example, if you use facial recognition AI, what's the risk of misidentification and what's the societal or legal impact of that? You have to prioritize the high-impact items. And third is treatment. You implement the necessary controls, human intervention rights, bias checks, security measures to reduce those prioritized risks down to an acceptable level.
And what about the positive side of planning? Setting the goals.
That's setting smart AI objectives. Your objectives have to align with both your business strategy and your ethical compliance goals. So they must be specific, measurable, achievable, relevant, and time-bound.
Can you give an example?
Sure. An objective might be: reduce the gender bias score on our hiring algorithm by 15% within Q4. And crucially, you have to define performance indicators metrics to measure not just technical accuracy, but also fairness, compliance, and explainability. This is what sets the stage for being auditable later on.
With planning complete, we move into the operational phase, starting with Section 7, support. This clause addresses the resources, competence, and documentation needed to make the entire plan a reality.
This clause is all about feasibility. Without adequate support, the aims just remains a theoretical document. Organizations have to allocate resources. Financial, technological, like specialized AI monitoring platforms are hardware and human. And the human element is often the biggest hurdle. Do you have skilled people who understand both AI engineering and ethics and compliance?
That brings us to competence and awareness. It's not enough to just hire a data science team. They need specific training on this standard, right?
Absolutely. 42001 mandates mandatory targeted training programs. Data scientists need training in bias mitigation and XAI techniques. Executives need training on their governance and accountability roles. Legal teams need updates on regulatory changes.
And everyone else needs general awareness.
Exactly. The entire organization needs to have awareness regarding the importance of the aims. If a technician handles data, they need to know their role in data governance.
And the documentation component, how is that uniquely focused on AI systems compared to other standards?
Well, while all ISO standards require policies and procedures, 42001 puts a heavy emphasis on data and model traceability. This is your proof for accountability. You must maintain detailed records of the training data used, the testing results that validated your fairness metrics, the specific model version you deployed, and all operational changes. This level of documentation is critical for auditors if they need to reconstruct an AI decision pathway.
Section 8, operation. This is the big implementation clause, governing the practical management of AI systems from start to finish. This is where all that theory becomes operational procedure.
This is really the meat of this standard. It details all the necessary operational controls across the entire system lifespan.
Let's walk through the mandated AI system lifecycle again, but this time focusing on the required controls at each of the 6 phases.
Okay. It begins with planning and design, where you define not just the technical goals, but the necessary human oversight levels and the initial ethical constraints. Then in development and training, you must use data that has passed quality and bias checks, integrating fairness metrics early in the process. Next up is testing and validation, which goes way beyond standard QA. You have to test the model specifically for explainability, for bias adherence, and for compliance with the objectives you set back in the planning phase.
Okay, so when the system is actually operational, what controls are mandated then?
During deployment, you have to establish monitoring, logging, and fallback mechanisms for your critical systems. Then operation and monitoring is continuous. You're tracking performance, security, and ethical adherence in real time. This phase requires key AI controls like automated bias and fairness checks and clear human oversight mechanisms that allow for intervention or correction.
And what happens when the model is retired? You can't just switch it off.
No. The final phase, decommissioning, is vital. You must safely retire the system, archive the necessary data for traceability and legal requirements, and update all your records. The standard forces organizations to treat AI systems as enterprise assets with finite auditable life cycles. It prevents abandoned models from becoming future liabilities.
Okay, Section 9, performance evaluation. We've operated the system, now we have to verify that the AIMS is effective and that it's actually achieving its objectives.
Verification is everything. This clause ensures that the AIMS is working as intended and meeting all the ethical and regulatory requirements you defined in the planning stage.
How does this change the way we measure success for these systems?
It changes it through monitoring and measurement. Organizations have to define and track KPIs that cover technical performance like accuracy and uptime and ethical compliance.
So things like fairness scores, explainability metrics.
Exactly. And incident rates related to bias. This requires specialized tools to monitor these more nuanced metrics continuously.
And how is this all formalized for leadership review?
Through two key processes. First, internal audits, regular, independent checks to ensure compliance with the 42001 clauses and your own internal policies. Second is the management review. This is a formal leadership meeting where the results of those audits, the monitoring data, risk profiles, stakeholder feedback, it's all reviewed. And that review guides future strategic decisions and resource allocation.
It keeps the aims aligned with strategic goals.
Precisely.
Finally, Section 10, improvement and continual learning. This closes that PDCA loop, ensuring the aims adapts to new technology and new regulations.
AI is the definition of a moving target. So this section mandates that governance is not a static certification, but an evolution. Improvement is formalized by implementing corrective and preventive actions. So you identify root causes of noncompliance, that's corrective, and you address potential risks before they can materialize, that's preventive.
What's the high leverage insight here regarding this continuous improvement?
I think it's the necessity of established feedback loops. Information you gather during monitoring, from audits, from external stakeholder engagement, it has to flow directly back into policy updates, model retraining, and procedure changes. This cycle of continuous learning is essential because model drift and regulatory change guarantee that what was compliant yesterday might not be compliant tomorrow.
We've navigated the 10 clauses. Now we transition to what is maybe the most critical part for our listener, the application. How does an organization actually go from reading the standard to implementing a functional aims? Let's break down that 9-step actionable roadmap.
Right, the transition from theory to practice requires phasing and prioritization. These steps provide a structured pathway to certification and, more importantly, to embedded responsible AI governance.
Step 1. Assess AI readiness. This sounds like an internal checkup.
It is. You have to conduct an AI maturity assessment. This involves a comprehensive review of your current AI projects, your data readiness, any existing governance structures you might have, and whether your internal culture really values ethical deployment. You're identifying all existing AI systems, and using the principles of 42001, you're assessing their current risk profile. The output is a clear gap analysis. Where are we already compliant? And where are the non-negotiable deficiencies we need to address first?
Step 2. Define strategy. How should a company decide whether to roll this out enterprise-wide or to start small?
The strategy should usually start with high-impact areas. You define your goals for compliance and improvement. Most successful organizations, they choose an incremental approach.
A pilot project.
Exactly. They start with 1 or 2 critical high-risk systems as pilot projects. This lets them build the governance structures and test the controls in a controlled environment. Once that's perfected, the aims can be scaled. It balances the need for enterprise coverage with minimizing the initial disruption.
Step 3. Build the governance structure. Who exactly needs to be at that AI governance table?
This absolutely cannot be siloed in the IT or data science department. You must establish a cross-functional AI governance committee. The critical roles have to be represented: legal, risk management, HR, operations, and top management. This committee is then responsible for approving AI policies, reviewing high-risk models, and ensuring clear decision frameworks are in place.
What's a common lesson learned if this step is done poorly?
That governance without clear roles leads to bottlenecks and inconsistent ethical standards. If the data scientist doesn't know who signs off on the final bias test, the model deployment just stalls. Clear decision rights are essential.
Step 4. Prioritize critical AI systems. How do we define critical?
You define it based on the risk assessment from Section 6. Critical systems are those with the highest ethical, operational, or regulatory impact. A system that automates basic email sorting is low impact.
But a system that determines loan eligibility or patient treatment pathways
Is very high impact. The principle is risk-based prioritization. Address the high-impact systems first. Make sure your resources are focused where failure would be most catastrophic.
Step 5. Implement key controls. Let's make this concrete. Give me an example of an operational control that has to be put in place right away.
One of the immediate ones is implementing formal human oversight mechanisms for any high-risk AI decision. This means defining the exact circumstances under which a human must intervene, the procedure for overriding the AI's decision, and documenting the reasoning for that override. Another critical control is formalizing your bias and fairness evaluation processes, moving from ad hoc text to mandatory scheduled audits against defined fairness metrics.
Step 6. Develop metrics and monitoring. You've stressed that these have to go beyond just technical accuracy.
Yes, you define KPIs for performance, operational integrity, and ethical compliance, specifically fairness scores, explainability metrics, and detailed incident logs related to bias or error. Then you implement automated monitoring tools and dashboards to track these metrics continuously. The insight here is that you need to monitor the system's behavior out in the wild, not just its performance in a lab environment.
Step 7. Train and engage stakeholders. What's the difference between this and the general awareness we discussed earlier?
This is targeted competence-building training. Data scientists need technical training on mitigation techniques. Executives need training focused on governance accountability and the financial implications of non-compliance. A really powerful best practice here is using practical case studies, real-world examples of bias or operational failures, to demonstrate the real impact of these lapses. That kind of competence building sticks.
Step 8. Continuous learning and adaptation. This formalizes that PDCA loop we talked about.
Correct. You formalize the feedback loops. The key requirement here is making the process mandatory. Audit findings must automatically trigger corrective actions. Lessons learned from deployments, both successful and failed, must be documented in a central knowledge base. You have to establish a process for regularly updating policies and controls based on tech advancements and the emerging regulatory landscape.
And the final step, number 9, scale and integrate. This is the payoff embedding aims permanently.
Once the pilot is successful, you scale the aims to other business units. And most importantly, you integrate the new AI controls seamlessly into your existing ISO management systems, 9001, 2901, 31000. This avoids parallel infrastructure, it optimizes resources, and it ensures AI governance becomes an intrinsic part of the enterprise's operational DNA.
Let's expand on that integration piece, because that's really where organizations save money and avoid that extra burden feeling. Give us 3 specific examples of how that integration works in practice.
Okay, let's start with cost. Think about the cost of building new security infrastructure. If you already have ISO 27001 governing your data centers, you simply leverage those existing security controls, your encryption standards, your access management, physical security, to protect your proprietary AI models and their training data. The scope of your ISMS expands, but your security hardware doesn't necessarily duplicate.
What about leveraging the existing risk review cycle? That seems efficient.
It is. If the organization has an active ISO 31000 system, their enterprise risk committee already meets quarterly to review threats. You don't create a new meeting. You map the new ethical and operational AI risks directly into the existing risk register using the same scoring methodology, likelihood versus impact, and the same review cycles. This ensures AI risk is treated with the same seriousness as financial risk, but without creating new administrative overhead.
And what's the smart way to handle the internal verification requirement, the audits?
You integrate the auditing process. Instead of conducting a standalone AI audit, you schedule your 42001 audit checks. For example, verifying data traceability or fairness metric tracking alongside your existing compliance audits, like financial compliance or cybersecurity reviews. This integrated audit program maximizes the efficiency of your internal resources and your external auditors.
That structural guidance is invaluable. Before we close out, let's synthesize some of the best practices, the wisdom gleaned from organizations that have actually gone through this process.
Starting with governance best practices, I'd say the key is making the governance board cross-functional. Don't let engineers govern ethics alone. You have to include HR for bias implications, legal for regulatory compliance, and operations for failure mitigation. The lesson learned is that centralized decision-making with dispersed input prevents delays and ensures holistic ethical standards.
And what's the key insight regarding risk and ethics management during the actual development process?
That proactive risk management saves immense cost. The cost of retrofitting bias mitigation into a deployed model is exponentially higher than designing for fairness from the very beginning. Best practice mandates dynamic risk registers that continuously update risks based on real-time monitoring and model drift, rather than relying on static annual risk assessments.
And operational excellence. How do we prevent the system from failing due to some internal process error?
You have to treat AI systems as critical enterprise assets, just like a financial system. This means implementing rigorous, automated version control and traceability. We've seen failures happen because an older, unvalidated version of a model was deployed by accident. For 2001 operational excellence requires tracking data sets, model versions, and decision logs meticulously to ensure continuous accountability and prevent human error from causing a catastrophic failure.
And finally, the cultural piece. You can have the most technically perfect aims, but it can fail if the culture isn't right.
That's so often overlooked. Cultural and leadership support is more decisive than technology. Organizations have to actively foster a culture where employees feel psychologically safe to raise ethical concerns, a whistleblowing mechanism specifically for AI ethics.
Because if they're afraid to report an issue,
Right. The lesson is that if employees are afraid to report a potential bias issue they see in the training data, that failure will eventually become a public incident. Ongoing role-specific competence training is what maintains that cultural commitment.
we have completed our comprehensive instructional deep dive into ISO IC 42001. We started by defining the aims and its strategic imperative. We explored the structural advantage of the Annex SL high-level structure, and we sequentially dissected all 10 main clauses, from context and planning all the way to operation and continual improvement.
And crucially, we laid out that 9-step actionable roadmap for achieving robust, ethical, and integrated AI governance.
This standard really represents a watershed moment.
It does. It signifies the industry's transition from viewing AI as a purely technical problem to treating it as a core management system challenge. It ensures organizations maintain active control over their AI deployments, driving value while systematically minimizing all those ethical, legal, and reputational hazards. It is, unequivocally, the roadmap to responsible innovation in the 21st century.
And we want to leave you with one final thought based on the required measurements that are detailed in the standard. We learned that ISO 42001 requires organizations to track metrics not just for technical performance like model accuracy, but also for ethical and societal impact. That means fairness, explainability, and bias mitigation. This raises an important question for you to consider. If the definition of a successful AI system now includes metrics on ethical performance and explainability, how does this shift in required KPIs fundamentally change the performance expectations, the required competencies, and even the career progression path for a data scientist or an AI developer?